Okay, so here we are. We're talking about the properties of metals and nonmetals. We've talked about physical properties before, but today we're going to relate them directly to the periodic table and the properties that certain things have. This is the reference in your textbook for where this is found. So don't be afraid to go in there because I'm going to ask you to eventually go in and find some definitions a little bit later on. You'll remember from yesterday's lesson or from last class's lesson, pure substances are divided into two subsets, elements and compounds. And elements are further divided into three areas: metals, metalloids, and nonmetals. And so what we're doing today is we're comparing metals and nonmetals, and you're going to see some patterns that are going to form. Remember, all of these things, metals, nonmetals, and metalloids, are all types of elements, and elements are made up of only one type of atom. Okay, so that's something that we need to remember. These are all pure substances, and these are made up of one type of atom, and they all appear on the periodic table. So what we're going to do is you'll notice this column here is the physical properties that we've talked about, and then we're going to go down and we're going to compare metals and nonmetals. So the first that we're going to look at is the state, solid, liquid, or gas at room temperature. And so 20 degrees Celsius is about room temperature. So a metal is a solid. Metals, all of these solids on the periodic table are solid. Okay, so they're all in one state. There is one exception, and the one exception happens to be the only metal that's a liquid at room temperature, and that is mercury, Hg, and it is a liquid at room temperature. So it's the exception. Nonmetals, their state is difficult to predict. Some of them are solids, one is a liquid, bromine's a liquid, and some of them are gases. So it's a little bit more difficult to predict what their state is. All right, color. All metals are a silver color. Okay, so they're all kind of silvery in color. There are two exceptions. The first one is, of course, gold, and it is, you know, the color of gold. It's kind of a goldy color. And the other is copper, and copper is, of course, a little bit more orangey red. Again, with the nonmetals, their colors are difficult to predict. Bromine is kind of an orange-red color. Sulfur is yellow. Oxygen is colorless. Nitrogen is colorless. Iodine is a purple-gray. Chlorine gas is green. And fluorine is kind of a yellow. So again, the colors of the nonmetals, difficult to predict. Luster is the next on our list. And as it turns out, all metals are lustrous, which means they're shiny. Nonmetals are dull. Okay? So all of these have no shine to them. They are non-lustrous. All right, so you'll remember that the next category is workability. So this is how malleable is it and how ductile is it. Recall that malleable is the ability to hammer it into a thin sheet, where ductile is the ability to pull it into a string or a thread. Metals are malleable and ductile. The most malleable is gold. Okay. As it turns out, the nonmetals are brittle, and so they are not workable at all. Electrical conductivity and heat conductivity, these go together. Both metals are both excellent conductors of electricity, and they're excellent conductors of heat. Okay, the best conductor is gold, and that's for, we have to be careful here. The best conductor of electricity is gold. The best conductor of heat is silver. Okay, the second best conductor of electricity is copper, and the second best conductor of heat is also copper. Okay, as it turns out, nonmetals are both non-conductors of heat and electricity. All right, so moving on down the list here, we have one more category, and that's attracted to a magnet. It turns out that only some metals are attracted to a magnet. Those are iron, cobalt, and nickel. Okay, these are what we call the ferromagnetic elements, and they're found as magnetic in nature. There's also rare earth metals, neodymium and samarium. These are not necessary for you to memorize, but they are the rare earth metals and they're magnetic as well. And as it turns out, nonmetals are non-magnetic. All right, so the next thing here is just a little bit of a refresher. I would like you to make sure that you define luster, malleability, and ductility. You may have to use your notes from Unit 1, or you can look back in this lesson. Perhaps you have a pretty good idea of what luster is, malleability, and ductility. The last thing that we're going to talk about is metals, nonmetals, and metalloids, and their placement on the periodic table. So on the periodic table, there is a zigzag line. It's a staircase, and that is what separates the metals from the nonmetals. So metals are to the left of the zigzag. Nonmetals are to the right of the zigzag. And the metalloids are adjacent. And another word for adjacent is beside the zigzag. All right. So a metalloid is an element that has the properties of both metals and nonmetals. Okay, so it's a special class that has either in-between properties or some properties of metals, some properties of nonmetals. And what I'd like you to do is I'd like you to, using your textbook, I'd like you to list the metalloid elements. And we will take this up when we get into class. Okay? Finally, based on their location on the periodic table, okay, so I want you to look up these two elements, tungsten and ytterbium. And I'd like you to state, is it a metal or is it a nonmetal, based on its position relative to the zigzag. And then if it's a metal, what do you think its qualitative physical properties are? All of these things that we talked about up here. If it's a metal, what do you think it might be? And I would say, I'd be looking at this column to say, if it's a metal, it's probably going to have these properties. If it's a non-metal, it's probably going to have these properties. So that's your assignment now on your own, and we will take up the rest of this note in class next period.